tuning in again, and today we will be talking about two-dimensional motion and vectors. A vector is a physical quantity that has both direction and magnitude, like velocity, while a scalar quantity just has magnitude, like time or distance. Vectors added together are placed head to tail from each other. The resultant is a vector representing the sum of two or more vectors. To find this, you can draw it in a triangular format. You can add them in any order and subtract them by adding the opposite. To find the magnitude of the resultant, you can simply use the Pythagorean theorem. In order to find the direction of the resultant, you must use sine, cosine, or tangent functions in a right triangle. For example, if you go 11 kilometers north and 11 kilometers east, what's the magnitude of the vector's sum? First, you draw out the added vectors using head to tail. Then use a squared plus b squared equals c squared to get the resultant, which gives you 15.6 kilometers. Next, we need to find the angle measure. Using SOHCAHTOA, you would use sine, opposite over hypotenuse, which equals 0.7051. Plug it in as the inverse sine, and you get 45 degrees. This is the direction of the vector. The next thing you need to know is a vector can be resolved into its component vectors using sine and cosine functions. To show this, we will find component velocities of an airplane traveling 300 meters per second at a 40-degree angle with the ground. We must find the horizontal and vertical velocities of this, since they will be different now. To find the vertical velocity, we use sine of 40 multiplied by 300. And to find the velocity of the horizontal, we solve 300 times cosine of 40 degrees. Make sure your calculator is in degree mode for this. Next, we will talk about projectile motion. Projectiles are objects thrown into the air and subject to gravity. The projectile path follows a parabola shape. At the top of the projectile is only the horizontal velocity. Horizontal velocity of a projectile is constant for us, but really it is not a parabola due to the Earth's atmosphere. Also, projectile motion is free falling with an initial horizontal velocity. The x-axis motion is separate from the y-axis motion. When a ball falls with zero horizontal initial velocity and lands at the same time as one with horizontal velocity, it means they both free fall at -10 meters per second from Earth's gravity. This is why they land at the same time. In order to find maximum range, you must use a 45-degree angle. It gives the projectiles to go the farthest. So far, we have done projectile motion problems where an object falls down, where delta y equals negative. Also, where an object goes up and down back to the same level, whereas delta y equals 0, and when an object is being thrown up to something, whereas delta y is positive. Now we will be doing one of each of these problems. The first problem is, a horse runs off a cliff at the speed of 4 meters per second and lands 2 meters from the cliff. How tall is the cliff? First, we need to state what we know. We know delta x equals 2 meters. We know Vix equals 4 meters per second, and Vfx equals 4 meters per second. Also, acceleration on the x side equals 0. We do not know delta y because we're trying to find it, and Viy equals 0. We do not care about Vfy, and acceleration on the y side is always negative 10 meters per second. We use the x-axis stuff to find time. Time equals delta x over the velocity of x. So that would be time equals 2 over 4. The time is 0.5 seconds. Now we use time to find delta x. Delta x equals Vi time plus 1/2 at squared. Since Vi is 0, that cancels out, so we have 1/2 at squared left. A equals negative 10 times 0.5 squared divided by 2 is negative 1.25, but since it is in height, we can change it to positive. So the height of the cliff is 1.25 meters tall. The second type of problem we're going to do is, Sarah throws a rock at Fred with an initial velocity of 20 meters per second at 35 degrees. What distance should Fred stand so Sarah can hit him? First, we need to find Vix and Viy. To find Viy, we would do 20 times the sine of 35, which gives us 11.5. To find Vix, we use 20 times the cosine of 35 degrees, which gives us 16.4 meters per second. Next, we need to find the time. Time equals Vf minus Vi divided by A. So we would do negative 11.5 minus 11.5 divided by negative 10, which gives us 2.3 seconds. We use the time to figure out delta x. Delta x equals Vx times t, which is 16.4 times 2.3. This gives us 37.72 meters. Fred needs to stand 37.2 meters away in order for Sarah to hit him with the rock. First, we need to find Viy and Vix. To find Viy, we would do 50 times the sine of 65, which equals 45.3. To find Vix, we would do 50 times the cosine of 65, which equals 21.1. Next, we need to find time with the y stuff. Time equals Vf minus Vi divided by acceleration. This would be 0.0 minus 45.3 divided by negative 10, which gives us 4.53. We use this to find delta x, which is Vx times time. This is 21.1 times 4.53, which is 95.583 meters away. The baseball player should stand 95.583 meters away from the scoreboard in order to hit it. This covers all the problems we have done, and now for physics in the news. Lately, an Australian skydiver has leaped free falling from space to Earth and actually broke the sound barrier. It gives scientists data for high altitude escape systems. It will be very beneficial for the future. That's all I have today.